All right, we're going to continue our discussion with dependent versus independent variables. So now we're talking more about the rate of change. So how is the slope or rate of change relationship determined? So we determine if the relationship is positive, negative, or zero, and then determine the rate of change. So our different steps to follow. The first step would be, do both values increase? Does one value increase, the other decrease? Does one value not change? So we're determining if the relationship is positive, negative, or zero in the first step. The second step is to determine independent and dependent variables. And then do the change in y and over the change of x. So this is kind of like what we've been doing the last few examples in the last video. So now let's take a look at 3 examples here. We have the first example saying tickets to Valley Fair back in my day were $30 for 2 and $45 for 3. So the first thing I want to do is figure out what the independent and dependent variables are. So we know that the ticket prices change depending on how many tickets there are. So our x value is going to be the number of tickets. And our y value is the price. So x is our independent, and y is our dependent. Now we can make that chart here. X and y. Our first x value is when we have 2 tickets, and our price is $30. Our second x value is 3 tickets, and our y value is $45. Now I want to figure out what the jump was between the y's and the x's. For the y's, we added 15, and for the x's, we added 1. Now we can write it as the rate of the change in y over the change in x. So we have 15 over 1. And what that means is for each ticket costs $15. So each ticket costs $15. Now I want to notice something about this rate of change. This rate of change is positive, so it is going to be that both values are increasing, so it'll look like this line. Now let's talk about the late fee for movie rentals. The late fee is $2 on the first day and $2 on the 7th day. Wouldn't that be nice? So we have the different variables we have are the number of days and the price for each day. So x is going to be days and y is going to be the cost of the movie for each day. So days, that would be independent, and y would be dependent. Now we can write our nifty chart, x and y. On the first day, it is a $2 late fee, and on the 7th day, it is also a $2 fee. Now let's go ahead and check what our change in y and our change in x is. So our change in y, we did not change at all, so it will be 0 change. And our change from 1 to 7 was plus 6. So this is a case, we're going to flip back to the first page when we talked about the rate of change. When it was 0, the line was horizontal. So the x changes, but the y does not. So that's going to be our rate of change. Our rate of change is going to be 0 because our x value changes, even though our y values do not. So our rate of change equals 0. What that means is that each day, no matter what, it's going to cost you $2. Each day will cost $2. And our last example in this video, for a house not built on time, the price paid is reduced by $50 after 2 days and $75 after 3 days. So we need to figure out which is going to be our x and which is going to be our y, or our independent and dependent variables. So the price depends on how many days after the house is built. So x is the number of days, which is the independent variable, and y is the price, which is the dependent variable. Now let's go ahead and draw that chart in, x and y. So the first day, it's reduced by 50, so we're going to have minus 50. And 2 days after, so now let's make our nifty chart in the corner. We have x and y. So it's reduced after 2 days, so x equals 2, and we're decreasing, so negative 50. And $75 after 3 days. So after 3 days, it's going down by $75. Now we want to figure out what that jump is between the y's and the x's. So from negative 50 to negative 75 was a negative 25 decrease. And from 2 to 3, we add 1. So we can write the change in y over the change in x as negative 25 over 1. So I want you to notice that our change is negative, so it's going to look like this. So even though our x value is increasing, our y value is decreasing. So what this means in terms of the problem is that every day late that the house isn't built, they owe, or the price is reduced by $25. So now I want you to go ahead and try those problems out in the You Try section, and good luck.